My name is Jacek Matulewski. The experiment, the result of which I will present, was conducted by Paweł Drojecki, a cognitive science student, while a data science student, Wojciech Sobczuk, analyzed the obtained results. The fundamental problem for designing a gaze-based human-computer interaction is related to the development of an effective method for activating graphical user interface elements using only the eyes. It is with no physical button or voice commands. Such a method should be easy for the user to apply. However, at the same time, it requires eye movements that are clearly different from the natural behavior of the eye to distinguish them from natural eye movement during the screen exploration or as a reaction to change in stimulus. This issue is usually referred to as the Midas touch problem. The experiment was performed as part of the process of developing a software library of net framework gaze-aware components for developers of gaze-controlled software. This library contains a text entry system, a component for number entry, and a set of basic gaze-aware visual controls, including, of course, gaze buttons. In this context, we decided to check the activation method's efficiency once again. We examined three methods of button activation by gaze. The most standard method, based on the use of dwell time, was our reference method. Firstly, we compared it to a similar method based on detecting fixation inside the button area. Activating a button with fixation requires an analysis of eye movement events, namely detection of fixation and saccades, performed in runtime. In this experiment, an algorithm detects fixations, considering the gaze position dispersion. The condition for activating the button is to detect a fixation whose center position is located within the boundaries of the button. In this study, the first fixation detected activates the button, but the software makes it possible to select the required number of fixations. We calculate dispersion, that is, the distance between the extreme vertical and horizontal positions, for a fixed number of 5 samples, and check if it is smaller than 10 pixels, separately for each direction. If so, we assume that fixation began. Despite all analytical machinery used, the method based on fixations from the user's point of view is quite similar to the dwell time method. However, the fixation-based method can be expected to be faster if we assume that the first fixation on the button means that the decision to select this button was made by the participant. Obviously, this is not always the case, so there is a risk of accidental activation, which may lower the entry speed. This is why we decided to empirically check this method's efficiency and usability and compare it to the dwell time one. The second method we have compared with the standard one was the method based on gaze gesture, consisting of movement into the button area and outward movement in approximately opposite direction. The angle should be no larger than, let's say, 45 degrees, but this parameter may be adjusted. In addition, these two movements may be separated by keeping the gaze within the button area for a certain short period of time. We use the term movement with an accent to describe it to the experiment participants. We call this method enter and leave. Two layouts of buttons were used, arranged on a grid, like in the case of telephone pad, and on a circle with an open center. The experimental task was to enter a set of 4-digit pins using a set of gaze buttons corresponding to 10 digits. A group of novices were instructed to use all the three activation methods and both button layouts, which gives 6 experimental conditions. The activation methods were compared in terms of system usability, objectively measured by the pin entry speed and the number of errors, as well as using a subjective system usability scale. 37 non-disabled participants with no previous experience in using gaze-controlled software took part in the experiment. Head movement was not restricted in any way, but the participants were instructed to keep both head as well as the entire body movement to a minimum. In the experiment, we used 3 presented methods of button activation and 2 button layouts, which resulted in 6 experimental conditions. The order of methods and layouts was random. All participants for all experimental conditions were asked to enter 14 four-digit pins taken from the fixed set but presented in random order. The numbers in this set was selected to take into account and balance the number of buttons in characteristic positions, directions of transition between buttons, the shape of paths, that is, angles they contain, and the need to bypass other buttons as well. During the entire session, each participant was asked to enter 84 pins. The pins to enter were visible on the screen on the left-hand side of the number pad and were also given by a speech synthesizer. Additionally, the moment when the entered pin became valid was signaled by the color change to the green and the word correct was displayed. There was also auditory feedback. The synthesizer read every entered digit. The eye movement data and the list of entered and removed digits with their timestamps were recorded during the experiment. It made it possible to calculate the temporary and average number entry rate as well as the number of errors. These values can be treated as objective measures of activation method usability. In addition, after each sequence of trials belonging to one experimental condition, participants were asked to fill a questionnaire of system usability scale. Then the participant had 90 seconds to rest before testing the next gaze button activation method. As said before, commonly in user experience studies, the time of completing the task and the number of errors are considered objective measures of exam systems usability. The same may be applied to gaze-controlled systems. Taking into account the time of performing the tasks, the gaze gesture-based method, the one we named enter and leave, is by far the least effective, while two others are similar. Because the completion of the task was based on complete and correct four-digit pin entry, we counted the number of backspace gaze button uses, excluding pressing the button many times in a series, and treated it as the number of errors. Also taking into account this measure, the method based on gaze gesture is the least effective. We have also calculated information entropy for the matrix of gaze transitions between areas of interest located inside the boundaries of all buttons. Entropy is the highest in the case of the method based on the gaze gesture, which is probably due to the nature of this method, but also shows that it requires more eye movements, which can cause eye muscle tiredness as well as mental fatigue. It takes about 400 saccades per trial for the enter and leave method, compared to about 100 for the two other methods. The results of system usability scale confirm that the enter and leave method stands out among all the presented methods. This method was assessed as the least useful. Its score was about 50 points for both button layouts, while the score for dwell time and fixation methods was about 80 points or higher. However, it should be noted that the distribution of points awarded by the users in the case of enter and leave method was much wider than in the case of other methods. One could even risk calling it homogeneous. A similar situation is visible in the distribution of times and the number of errors for this method. Thus, one may conclude that there is a certain group of people who feel comfortable with this method and evaluate it positively. This is confirmed by our observations during the experiment and by participants' comments. To conclude, the standard activation method based on the dwell time seems to be the most effective. The method using fixations shortens the single-digit entry time in the number entry, but the greater number of errors prevented it from being translated into an increased entry speed. However, it seems to be a promising idea if it only would be possible to distinguish between decision-related fixations and fixation associated with stimulus observation. The method using gaze gestures definitely has the lowest usability. Comparing button layouts, The one in which the buttons are arranged in a circle turn out to be more useful than the layout known from the telephones and other physical devices. In addition, I would like to list other gaze control software projects that I am developing together with students in our lab, in which we use the gaze buttons as well as other gaze control components. The gaze text entry library contains the dozen or so gaze keyboards, starting from the classical one, that is with dwell-time gaze buttons as described above, arranged as in QWERTY layout, through dynamical keyboards with moving elements, all the way to keyboards based on gaze gestures. Using gaze buttons, we also prepared an instant messenger that allows one to send SMSs and emails. It is convenient because it does not require any specialized software from the messages receivers. The gaze-controlled client for the YouTube service, the photo browser with the possibility of sharing photos with one's partner, her or his family and friends, the gaze board games, for example checkers and tic-tac-toe, and finally we prepared the gaze-controlled TV remote control with a dwell-time based gaze interaction interface, as well as with the one based on the gaze gestures. The whole set of software creates a kind of entertainment center for a person communicating with the environment only through his eyes. The software used for the experiment may be downloaded from the web address visible on the screen. It may be also treated as a demo of our gaze-aware components library. It requires .NET framework and Windows operating system. Thank you very much.